to recap, okay, so if I am differentiating, let's say for example 7x to the power of 6, okay, what would the answer actually be? What would the differentiation of 7x to the power of 6 be? This is differentiating with respect to x, okay, then after that 7x to the power of 6 is what we want to differentiate. So what would the answer actually be? Hello? Sorry? 42. 42x to the power of 5. Okay? So this is a combination of our power rule and then also our constant multiple rule. Okay? And then what if I want to differentiate, let's say, negative 8 over 5? What would the derivative of this be equals to? So what do you think? 0. Okay, great. So this is a constant number. So if you differentiate a constant number itself, it will become 0. Then likewise, if I were to have our sum and product, okay, so if I were to be looking at differentiation of, let's say, negative 35x to the power of 3 plus 7, 2x to the power of negative 1. Okay, then what would the differentiation of this equals to? Emily, what do you think? What would the derivative be? Differentiating with respect to x, this whole expression.
Negative 105x squared minus 2x negative.
Okay, we agree with this? Right, so we bring down the power of 3, so 35 times 3 is 105, negative, keep it there. Then after that, this one, negative 1 times 2 is negative 2, negative 1 minus 1 is negative 2. Okay, so this will be the derivative. So this is the application of our sum rule and difference rule, okay, on top of our other power rules and constant rule. Okay, so the last lesson we stopped at try 4 part B, am I right? Okay, so let's look at try 5. Where we will be looking at some form of a problem sum. Okay, so we are looking at this diagram that shows part of a curve with the equation y equals to 3x squared plus 2 over x. There is this point 213 which we label as A. In the first part of the question, they want you to find the gradient of the curve at part I 213, and then after in part 2 we want to find at the point where the curve meets the line y equals to negative x. So in this question, okay, how do we go about solving it? Is to first understand, okay, how does the application of differentiation actually come in. So in differentiation, the whole purpose, okay, or rather one of the applications of differentiation is that the derivative itself is going to be the measure, okay, of our gradient of the tangent. Okay, so one important point. Okay, so the derivative of a function is the gradient of, not say the curve, of the tangent. Of the curve. Okay, so this is the relationship that we need to draw, and that's the purpose, okay, of differentiation itself, that it is the gradient of the tangent. So understanding this, okay, it is a very, very helpful fact, okay, and that is actually how I usually go about determining in your Emaths whether the gradient of your tangent, okay, is it actually accurate or not. So if you remember last year when we did Emaths, okay, when we had to do, I think, chapter 5, where we drew a lot of graphs and then we had to draw tangents. You remember that? Okay. So when we drew the tangents, then after that I asked you to find out what is the gradient of the tangent. Then usually you will come back to me and ask me, is my answer correct or not about the gradient value. Okay, so how do I know whether your answer is correct or not? I very largely rely on differentiation. Okay, so after you learn this skill, it will be a very useful tool that you can use to check your answer about whether your gradient value itself is it within acceptable range. Okay, so you can justify for yourself to check. So usually you will be able to get a very accurate and very exact answer in differentiation. But of course, when it comes to live drawing, there is some range that we allow. Okay, so you can see whether is your answer close enough to the exact value or not. You don't have. It's not possible to get the exact value. Okay, by drawing, we can only achieve it through computer most of the time. Right. So following up on this question, okay, we want to find out what is the gradient of the curve at the point A 213. So what we will first do, okay, is given this equation of the curve, we differentiate it first. But it may be a bit difficult to differentiate fraction in it, so we re-express it to be in this manner. Okay, before we differentiate and have dy over dx. So when we have dy over dx, okay, what would the derivative be? Joanne? 6x minus 2 over x squared. Okay, great. So because we get x power negative 2. Then now we want it to be at A 213. So at that point itself, we can see what is the x coordinate. We also have the y coordinate. But in the derivative, okay, we just have to substitute in the x coordinate into it. So the gradient will be equal to 6 times 2 minus 2 over 2 squared. Key that into your calculator and you would get 11.5. Okay, so this is the process that I always go through in finding out the gradient of my tangents. In part 2, we want to find the gradient at the point where the curve meets the line y equals to negative x. So we are not told specifically where that point actually is. So how do you think we could go about finding that first? What will you have done? Irvin? What will you do to find out where is this point? Three what? Gradient equals to negative 1. Okay, so why do you say gradient is negative 1? From this? Okay, so why do you want to say gradient equals to negative 1? It says the curve meets the line, but the line may not be a tangent, right? Are we on the correct point? We are talking about part 2 now. You told me gradient equals to negative 1. Right? So why do you say gradient is negative 1? Huh? You think first. Okay, so we saw that in part I, we needed to know where is the point first, right? Then we can substitute it into our dy over dx. Then we can get the gradient value. So the crucial thing over here is we must know where is that point. So how do we find that point? Yes, Joseph? Why must we take dy over dx equals to negative 1?
Because that fx is not easy x. That the value that 6x minus 2 over x squared is equivalent to the gradient. Yeah, the gradient.
It's equivalent to the gradient of what?
The gradient of wherever that point of the.
It is gradient of the tangent. Is y equals to negative x the tangent to this curve? It is. Which part of the question says that? Is this a tangent to this curve? It isn't, right? There is no part of this question that says that this is a tangent to the curve, am I right? Because they just say that it meets. It can meet anyhow that you want. You can have a graph like that and then they meet like that. This is also considered meeting. Meeting doesn't mean that you have to actually have a tangent. Right? Yes, so therefore we should be looking at simultaneous. Okay? So having our y equals to 3x squared plus 2 over x as equation 1 and y equals to negative x as equation 2. Okay, we will sub 1 into 2. So negative x equals to 3x squared plus 2 over x. Want to get rid of the fraction, the denominator, multiply across by the whole equation by x. And we arrive at a tricky situation that is having a cubic equation. Okay, so how should we go about solving this? Use calculator. Yes, of course you use your calculator in some way, but you still need to present an answer. So how? Do you remember how to solve cubic equation? No. Okay, revise Alright? So you use your calculator, if you remember, cubic equation, we use calculator, key in our 3, 1. Do we need to use factor theorem? Yeah, you need. That's the process that we need for solving a cubic equation. And so what do you mean by writing it down? Yeah. I'll run through the steps. Yeah. Okay, so we will use calculator first one, right? Usually. Okay, we press the calculator. A is 3, B is 1, C is 0, because there's no term in X. And then D is 2. So what do you see in your calculator? We get a negative 1/3 and a 0, right? Okay, but we don't use that to write down x equals to negative 1/3 or x equals to 0. We never ever do that. Okay, because we must go through the process. We cannot tell the examiner we use the calculator, right? So we will use our factor theorem. Okay, so we choose that x equals to, I prefer to use 0 most of the time. I like to use whole numbers easier. Okay, so 3, 0 cubed plus 0 squared plus 2. Sorry. Did I press something wrongly? 3, 1, 0. Oh, because I pressed wrongly, no wonder. Sorry. Okay. 3, 1. Oh, why am I in this one? Oh, 3, 1, 0, 2. My bad. You should get negative 1. And then after that you get your imaginary numbers, a very long number. So let's choose negative 1. Okay, so our f, negative 1 equals to 3, negative 1 cubed, negative 1 squared plus 2. Now to show the substitution, you can press your calculator again. It should definitely be equals to 0. Okay, so therefore, we say that x plus 1 is a factor, and this is our factor theorem, right? This is how we apply our factor theorem. We sub in a number, we will know what is a factor. Do you remember that? Okay, I will not go back. I will not rewind to what half 1 year ago stuff yet. For now, Okay, so x plus 1 is a factor. Okay, then after that, what's the next step? Yes, do long division. Okay, so our 3x cubed plus x squared plus 2, x plus 1, 3x squared, and plus 3x squared. Okay, then we will see that our fx is equals to x plus 1 and 3x squared minus 2x plus 2. 3x squared minus 2x plus 2 cannot be further factorized. So when fx equals to 0, which is what we wanted to solve, okay, or 3x squared minus 2x plus 2 equals to 0. This one we can reject because there are no solutions. So if x equals to negative 1, we can now substitute it into our derivative. Earlier on, our derivative that we found in part I was this. So at x equals to negative 1, the question did not ask me to find out what is the point, or rather the coordinates of the point. So there's no need for me to further find out what is the y coordinate. So our derivative would be 6 minus 2. Did I do anything wrong here? Did I make a mistake in my calculation? Alright, yes, Rina. 6x. Oh, sorry, thank you. Okay, so we get our gradient to be negative 8. Huh? Okay, any questions? Alright, so need to start recapping about our cubic solving, yeah? If no questions, I'd like you to spend the next maybe 20 minutes. Okay, I want you to do a series of differentiation questions. You've got to practice. Okay, the series is I want you to do exercise 12.1, question 2C, 2F, 3A, 3B, 3C, 3D, 3E, 3F, 4C, 4E, 5A, 7C. Okay? My calculator? No, no? Yeah. No need, I got textbook. Okay, please do that now. Give you 20 minutes until about 1:05. Okay? If you got questions, please ask me. to squeeze up to 4C on the whiteboard. Okay, so you may want to check your answer. I am writing out in full presentation, okay, as for what you will be expected. So do keep a lookout at equivalence matters, okay, where your equal sign should be. Y and divided over dx should not be equal. Okay, I think I generally went around. I'm able to catch as much as I can already. But just do take note. Okay, it's a very, very common mistake, and that causes a lot of loss in marks, okay, most of the time. So, and it all starts from classwork. Okay, then 3D and 3F. Okay, sorry, 3D and 3E. I am offering two different other ways of presenting. If you want to do it in the function form, then you'll be using f prime x. Just now answer was asking me, what if it is like hx? It doesn't always have to be f, okay? It can be other smaller letters as well. Just that usually for functions we go by f, g, h. I've never seen I that much, okay? So this will be common letters that we use for functions. Okay, then it would then be h prime x in this case. So 3E, I'm offering another presentation where I'm looking at differentiation of the function itself. So I write down what is it that I want to differentiate. After, when I've done the differentiating, okay, I would have removed the notation. So no more d over dx. Okay? So do a check. Do we always leave our answer in radical form? Okay, I think that is just usual practice. Unless, of course, if my answer is like x equals to negative half, okay, then I can put it in square root x. But if my answer is, let's say, x to the power negative 3 over 2, then it isn't very convenient for me to leave it as 1 over x cubed, square root x cubed. So I don't have the... Huh? It's okay if you do this, but it must be correct. Yeah, if you do it wrongly, then too bad. Okay? Okay, any questions? From that all the way to 4C. Okay? Are there any issues with 4E and 5A? No? Or do you need more time to do? Okay, I'm looking at the time now. Alright, 4E, 5A, and question 7 of 12.1. I will go through it the next lesson, which I think is tomorrow, right? Yeah. Okay, I'll go through it tomorrow. Then after tomorrow, I'll also finish up with one more question and we will wrap up the 12.1. Then we'll move on to 12.2. Okay? Okay? So, I'll end here. You can go for your lunch. Lunch right next. Okay, you'll go for your lunch. I'll come back later on, 40 minutes later, for E-maths.